Hello everyone, welcome to eMath Edge. My name is David Akashki and I'm here to help you master mathematics and give you the edge you need to succeed in your exams. Here at eMath Edge, I will practically be solving mathematics past questions from senior school exams, where I will be breaking down the whole process into simple, easy to understand steps. I actually understand that preparing for math exams can really be hectic, but believe me, understanding how to approach these questions, most especially the essay part, will ease you a whole lot of stress. And that is what this platform is designed to do for you. Each video tutorial is designed to boost your confidence and make math exam feel less like a mystery, but more like a basic thing you can conquer. So with that being said, let's get started. So now we have a wild question for 2013, question 5b, which carries a total mark of 7. And the question says, solve the equation. And what is the equation? The equation is 2 cos square x minus 3 cos x plus 1 is equal to 0. 2 cos square x minus 3 cos x plus 1 is equal to 0. And the condition is given to be 0 degrees is less than or equal to x, which is less than or equal to 360 degrees. So what this condition is actually saying is that whatever value or set of value you are going to obtain for x must range from 0 down to 360 degrees. So now let's go further and solve solution. Now here comes the question. If you look at this question, it is not far from quadratic equation. You know, quadratic equation have the highest power of 2, such that we have something like 2x squared plus 3x plus 6 to be equal to 0. This is the nature of quadratic equation, right? So if you look at this equation closely, you will notice it's not far from quadratic equation. It's just that we have cos instead of x or any other variable. So what we are going to do is we are going to assume cos or cos x to be a single variable so that we can transform the equation to be a quadratic equation for it to be easy for us to solve. So let's bring up the question. We have it to be 2 cos square x minus 3 cos x plus 1 to be equal to 0, right? But let's cos x be equal to y. Now what we want to do is to transform this equation to be a quadratic equation. So if we transform this, the equation becomes so instead of cos x, we are going to have y, right? And here we have cos x squared or cos square x. So we are going to have 2y squared, mind you, is cos square x. So it's going to be y squared minus 3. Instead of cos x, we are going to have it to be y plus 1 to be equal to 0. So if you observe, this is nothing but a quadratic equation. 2y squared minus 3y plus 1 equal to 0 is a quadratic equation. So what we are going to do now is to use any of the quadratic methods to solve this quadratic equation, either the elimination method or the quadratic formula or possibly the graphical method. So now let's use quadratic formula to solve this equation using the quadratic formula. And you know the quadratic formula is y equal to minus b plus or minus the root of, we have b squared minus 4ac all over 2a, right? Now this is the quadratic formula, and this is the quadratic equation we have to be 2y squared minus 3y plus 1 to be equal to 0. Now where we are going to have this set of values a, b, c. Mind you, the first term, which is 2y squared, the coefficient of y squared is going to be the value for a. While the second term, 3y, the coefficient of y is going to be the value for b, and the constant number is going to be the value for c, such that after obtaining those values, we can substitute them into this equation, which is the quadratic formula. So now, where we are going to have a to be equal to 2, which is the coefficient of y squared, right? And we are going to have b to be equal to 3, which is the coefficient of y. And we are going to have c to be equal to 1, which is the constant number in the equation. So having obtained these values, the next thing to do is to substitute it into this formula for us to be able to obtain the value of y, which we can now transform to be cos x. So let's quickly go ahead and do that. So now we are going to have this equation to be y equal to, now instead of minus b, we are going to have it to be, mind you, the coefficient of y here is minus 3, it's negative 3 and not just 3. So we are going to have it to be negative 3, not just 3, okay? The coefficient of y squared is 2, which we have it to be here. The coefficient of y is going to be minus 3, which we have it to be here, and the constant number is 1, which we have it to be here. So having all this value, the next thing we are going to do is to substitute the values into this formula. So we are going to have it to be minus, mind you, we have a negative sign here. So we are going to have this to be minus into the bracket of what is the value of b, negative 3, right? So it's going to be minus into the bracket of minus 3 plus or minus the root of, what's the value of b is minus 3, mind you, it is squared, minus 4 into the bracket of what is the value of b is 2, what is the value of c is 1, all over, we have 2 into the bracket of what is the value of a is 2, right? So with this, let's further simplify. For us to further simplify this, we are going to, open the bracket, and those with square, we are going to apply the square so that we can have a simplified value for y. So let's quickly do that. We are going to have this equation to be y equal to, now this is a negative sign multiplying a negative number, which is minus 3. So minus times minus is going to give us plus, and we are going to have this to be positive 3 plus or minus the root of, now this is a negative number also, minus 3 being squared, and when any number raised to the power of 2 or being squared is the same thing as that number multiplying itself. So minus 3 squared is the same thing as minus 3 times minus 3, and minus 3 times minus 3, minus times minus, we are going to have a positive sign, while 3 times 3 is going to give us 9. So that simply means that minus 3 squared is going to give us 9, minus 4 multiplied by 2 is 8, multiplied by 1 is going to give us still 8. All divided by 2 times 2 is 4, right? So let's simplify further. We are going to have 3 plus or minus the root of, now 9 minus 8 is going to give us 1. Mind you, it's all over 4. To further simplify, we are going to have 3 plus or minus. Now, what is the root of 1? The root of 1 is 1 all over 4. Now, this is going to give us two different values. This simply means that y is going to be 3 plus 1 all over 4, which is the same thing as 4 all over 4, which is the same thing as 1. Or y is going to be 3 minus 1 all over 4, which is equal to 2 all over 4, which is the same thing as 1 all over 2 when you simplify further. And that is because we have plus and minus here. So the plus and minus now simply means we are going to obtain two different values for y. Now we have the value of y to be 1 or 1 all over 2, right? But mind you, from the onset, from the beginning, we said let cos x be equal to y. So that's to say this value we obtain for y is the same thing for cos x. Since cos x is equal to y, that's to say the value we obtain for y now is cos x. So we can simply go ahead and say, since cos x is equal to y, this implies that cos x is going to be 1, right? Or 1 all over 2. So now for cos x, equal to 1, just like the previous equation we've solved, when you have cos x to be equal to 1, now what you are going to do is to check for the corresponding values in the trigonometric table, the corresponding values in degrees in the trigonometric table, and obtain the value of x. So now, since we have cos x to be equal to 1, what we are going to do is to go to our trigonometric table to check what value in degree or what angle in degrees corresponds with when cos x is equal to 1. So let's quickly go there. Here we have our trigonometric table and the value. So you look at the cos row. You look closely at the cos row and we have cos to be 1 at 0 degrees. We have cos to be the root of 3 all over 2 at 30 degrees continuously. So now we are looking at when cos x is equal to 1. And if you observe at this point, we have cos to be 1. And if you trace down to the angles in degrees, we have 0 degrees. So let's further check at what point is cos x equal to 1 again? At 360 degrees. Cos x is equal to 1. So let's quickly go back and state the value for x. So at this point we can conclude that therefore the value of x is equal to 0 degrees and 360 degrees. That's for cos x equal to 1. So let's further check for cos x equal to 1 all over 2. We still have to go back to the trigonometry table again to check when cos x is equal to 1 all over 2. So let's quickly do that. So here we have the trigonometry table, and taking the cos row, we have cos x to be 1 all over 2 at 60 degrees, and also cos x to be 1 all over 2 at 300 degrees. So we have cos x to be 1 all over 2 at 60 degrees and also 300 degrees. So let's proceed to bring out the value of x. So this simply means that, or we can say therefore x is equal to 60 degrees and 300 degrees. So in conclusion, we can say that the set of values for x are, we have 0 degrees, we have 60 degrees, we have 300 degrees, and 360 degrees. So these are the set of values we were asked to obtain, and mind you, it was clearly stated earlier that the value for x, or the set of values for x, must be from 0 degrees down to 360 degrees. So that's to say we are on the right track. So that will be end for this video. Stay tuned and engaged for the next one. Also remember that the goal of this platform is to solve as many past questions as possible just to help you overcome math exam tension. So if you have any challenging question from this topic, you can drop it at the comment section or reach out to me via email or DM and I'll be glad to assist. Thanks for watching and have a great day.